Hey guys, it's Rija Raju and today we're going to talk about statistical control process. What is statistical control process? At its core, it's just a way to monitor and control your process. Or in more technical terms, it's a way to analyze data that you have collected on your process to understand how it's performing and use that knowledge to ensure a normal controlled output. This process was first used back in 1920s by Walter Shewhart, a fellow engineer. Since then, SPC has been a vital tool for many companies in studying and controlling its process, output, or service using statistics. SPC can really help you comprehensively understand how your process is behaving. Studying the variation in your sample data gives you insight into your output productivity. You can use that insight to check the magnitude of variation to see if it's acceptable or not. If not, do further investigation into what is causing that variation and get your process back in control. After you conduct your statistical process analysis, the data you find is visually represented on a control chart. It provides engineers with an easy way to monitor and control and ensure uniform and better quality output. There are various types of control charts, but an underlying theme across all charts are three parallel lines that represent the center line, the upper control limit, and the lower control limit. 99.74% of all your data is expected to lie between the upper and lower control limits. Therefore, if any data falls outside your control limits, you can easily notice that something is wrong and quickly reassess the situation. Now let's bridge this topic over to an engineering application. Let's analyze the diameter of a 3D printed sphere that can be used for ball bearings. When we analyze the sample data with a sample size of 200, we see that the mean is 5.012 millimeters and there's a sample standard deviation of 0.163 millimeters. With that, we can calculate our upper and lower limits. The upper control limit equals to the process mean plus 3 times the process standard deviation divided by the square root of the sample size. With that calculations, you'll have an upper control limit of 5.121 millimeters and a lower control limit of 4.903. This conveys that the sample mean of the diameter should fall between 5.121 and 4.903 to have an in-control process. Finally, here are some possible conditions for control charts. A process that's in control will still have variation, but will be centered around the center line. If points fall outside the control limits, you know something is throwing the process off track and that issue needs to be fixed immediately. Thank you for listening. I hope you guys learned something. Have a great day.